Hello students, my name is Dr. Smita Sharma and I am working as an associate professor in AIML and cybersecurity department at SIRT Bhopal, and today I'm here to discuss about the topic hash function and its applications. And it is one of the recent topic that is basically connected to the cybersecurity. And basically, what do you mean by a hash function? It is a mathematical function that converts a input value into another compressed numerical value. Okay, and it basically plays a very important role in security system that creates a unique fixed length output for a message or a data set. And the next important point about the hash function is that the input to the hash function is of arbitrary length, but the output that we get after processing through hash function is always of fixed length. And the value that are generated by the hash function are called as message digest or hash values. Okay. So, as we can see through this diagram, that whenever a message M that is of arbitrary length is passed through a hash function, we always get a hash value H that is of fixed length. Okay, so this is the basic diagram that is used for representing a particular hash function. Next, we talk about the properties of hash function. Basically, the properties that are related to hash functions are the first one is deterministic. Uh, it means that the same message always results the same hash value whenever it is passed through the hash function. Okay, so no matter how many times we process a particular message through the hash function, we will get the same hash value. And the next property is avalanche effect. It basically means that a minor change or a small change made in the message will produce a major change in the hash value. Okay, and the next one is one-way function. One-way function means we cannot use a particular hash function to get the message. Okay, that is, it means a hash function is only one way. We can only get the hash value from a message, but we cannot use a particular hash value to get a particular message. Okay, the next one is pre-image resistance. This property means that it is very computationally hard to reverse a particular hash function. Okay, it means if a hash function h produced a hash value z, then it should be very difficult to find any input value or x that produces the hash value z. Okay, so basically, it protects us from the attacker who has only a hash value and it is trying to find the input or the message. Okay. The next one is second pre-image resistance. The second pre-image resistance means if a attacker has an input and its hash, it is very difficult to find a different input with the same hash. It means every message has a unique hash value. No two messages can have the same hash value. Okay, that is, if a hash function h for an input x produces hash value hx, then it should be very difficult or hard to find any other input value y such that hy is equal to hx. So basically, it means that no two messages can have the same hash value. Okay. So what is the advantage of this property? This property basically protect against an attacker who has an input value and its hash, and it wants to substitute different value as legitimate value in place of original input value. Okay, so it will not be able to get a particular message with the same hash value. Next is collision resistance. So when we talk about the collision resistance, it means it should be hard to find two different inputs of any length that result in the same hash. This property is also referred to as collision-free hash function. Okay, that is, for a hash function h, it is hard to find any two different inputs x and y such that hx is equal to hy. Okay, so it is very difficult for an attacker to find two input values with the same hash. And also, if a hash function is collision resistant, then it is definitely possess the property second pre-image resistance. Okay, that is all about the hash function and its basic properties. In the next class, we will go ahead with the next topic of cybersecurity. And thank you so much.